economic order quantity model for inventory control. This is a deterministic model as demand is known for a specific period. Graphically, how the inventory is functioning is shown by this graph. Okay. The condition is instantaneous replacement. Means at the moment the order is placed, the quantity order is received in the godown or production center when it is asked for. You can see this model. Suppose order is placed here, Q quantity is ordered, and when it is received, the inventory is taking the highest height of the quantity received. The consumption is uniform. That means uniformly the quantity Q is being consumed or used in the factory, or demand is being met, and for that reason uniformly this Q is being diminished or decreased and finally reached to the point zero. Again the next order has been received here and the inventory size is Q, and uniformly the inventory quantity is being used and finally reduced to zero. In this manner, the EOQ model is functioning. If you look to the graph, then you can see the loop is like a hacksaw blade, and that's why sometimes this model is also known as hacksaw model. In graph or picture, time is plotted on x-axis and quantity, order and receipt is shown on the y-axis. Now we are going to discuss the optimum ordering quantity. That means how much you will order at a time in units so that the total inventory cost will be minimum. That I am going to discuss with you. Then what are the assumptions? The assumptions are replacement is instantaneous, consumption is in uniform rate, and the demand is known for a specified period. Now see the workings. Let D is equal to demand per year, which is known in units. C, cost per unit of the material. CO is the ordering cost per unit. CH is equal to carrying or holding cost per unit of time. Carrying or holding is same. And Q is the ordering quantity in units. We have to determine the formula of Q for which the total cost will be in. First of all, total cost. We are taking here the total calculation for a year in the case of the specified year. We are taking for a year. You can take any period, you can take weekly, you can take monthly, even you can take even for a day, but we are taking per annum or per year. The total cost consists of three components as per this model: material cost, ordering cost, and carrying cost. Material cost means cost per unit is C, and D is the total demand. That's why total material cost per annum will be D into C. Cost per unit into total demand per annum. We are finding out the total cost per annum. Next, ordering cost. How many number of orders will be in the year, as D is known and Q is the ordering quantity at a time, and number of orders per annum will be D by Q. For placing each order, the cost is CO. That's why the total ordering cost per annum will be number of orders D by Q into CO. The third part is carrying or holding cost. How you determine it? First of all, we have to find out what is the average inventory for this model. You can calculate the average inventory, that is the inventory units in each moment. You can find in this way. This is the total inventory area. This triangle area is the total inventory for time t. The total inventory is half into base into height, half into base into height. This is the total inventory for time t. Then what is average inventory? Divide by t, that is Q by 2. You can find out the average inventory in different way also. The second method I have shown you. You take the initial inventory and then add the final inventory. the sum total divided by 2. Then you will get the average inventory. What is the initial inventory? Initial inventory is Q, because these are initial inventory and final inventory is 0. That's why Q plus 0 is the total inventory divided by 2. That's why this is the average inventory. Now we are coming to carrying cost. CH is the carrying or holding cost per unit of time, and holding units per unit, holding units per unit of time is Q by 2 on an average for inventories. That's why the total holding cost for the year will be Q by 2 into CH. And this is the total cost. We have to minimize this TC, total cost, with respect to Q, because Q is the variable in this case. All others are fixed, deterministic. B, C, CO, CH, all are fixed. That means we have to minimize this with respect to Q. What would be the value of Q for which the total cost will be minimum? We have to apply the calculus technique of optimization. The basic condition for optimization is d dTc dq is equal to 0. This is the necessary condition for either minima or maximum. So we have differentiated Tc with respect to Q, as this is the constant. This differentiation is 0, and the differentiation of this star will be minus dCu by Q square. You can check it, and the differentiation of this star is CH by 2, as Q differentiation of d dq is 1, for is 1 with this. This is the necessary condition. For optimization, that must be is equal to 0, as written in equation 3. For definite minimum of Tc, the second degree differentiation of this term must be greater than 0, that is positive. If it is negative, if the double derivative of this Tc with respect to Q less than is equal to 0, then it will be a case of maximum. But when it is greater than 0, that is positive, then the necessary condition, whatever we have calculated in 3, will be definitely minimum, whatever is required in this case. Now the double derivative we are checking is positive or negative. The double differentiation of Tc will be this. You can check it, because minus already given, minus 2 and power will be minus c minus 1. That's why this term, and here you can see B positive, C positive, Q positive, then all are positive. That's why this is positive. From 2 and 3, we can write this, and after solving, Q0 is equal to this. This is the optimum quantity, that is the best quantity for which the total cost will be minimum, and this is called economic order quantity.